All right, this is our last example for solving systems of linear equations using the elimination method. And this is the most challenging situation here. So we have 5x plus 6y equals 20. And we have 3x plus 8y equals 34. We know that this is not good to go. It's not ready to use elimination where we can just add up the equations, because if we add them up, we get 8x plus 14y equals 54. That's not going to help us. So this one, if I look to just try to multiply one equation by something to get the opposite coefficient of either x or y, I struggle here to find one, right? I probably can do it, but I'm going to have to deal with fractions. It's not going to be pretty. So this situation, I'm going to have to change both equations in order to get opposite coefficients. So how are we going to do that? So look at the coefficient of x first. We've got 5 and 3. I want you to think about the multiples of each of those numbers. Do they share a common multiple? Let's think about it. For 5s, 5, 10, 15, 20, 25, 30. Look at 3, 3, 6, 9, 12, 15, 18, 21. Did you hear that 15? Well, what would you have to multiply the top equation by to get 15? 3. The bottom one you have to multiply by 5. Then there's one extra step. We want to be opposite. So we want one to be positive 15x and one to be negative 15x. And one you have to multiply by a positive number and the other you multiply by a negative. If we want to do the y's first, we want to eliminate those first. Well, then think about the least common multiple for those. 6, 12, 18, 24. Okay, 8, 16, 24. So you want to get these to both be 24 and negative 24 for y. So this one you can multiply by maybe 4, top equation by 4. Then the bottom equation you multiply by negative 3, right? And now you get you negative 24y. All right, let's go ahead and start with the first way. We're going to eliminate the x's. So I'm going to multiply the top equation. I want that to be 15x, so I'm going to multiply by 3. All right, so then I get 15x plus, got to be real careful here, right? 3 times 6y, 18y equals 3 times 20 is 60. All right, the bottom equation, be careful again. We want this to be negative 15x now, right? So I multiply by negative 5. Negative 5. All right, so 3x times negative 5 is negative 15x. And then it's going to be minus, what's that, 40y? 40y equals negative, what is that, 170. Negative 170. All right, there's our system. Okay, so now what we're going to do is I'm going to add these together. So 15x and negative 15x, no x. 18y plus negative 40y, well, that's negative 22y equals 60 plus negative 170, well, that's negative 110. All right, we are going to divide both sides by negative 22. So I get positive y equals, 22 goes into that, negative 22 goes into that 5 times. So y equals 5. All right, now we're in business. So what we want to do now is we want to take that 5 and substitute back into one of the equations here for the y. Let's do the top equation. So I'm going to go 5x plus 6 times my 5 here for the y equals 20. All right, so then I get 5x plus 30 equals 20. All right, subtract 30 from both sides. 5x equals negative 10. And then I want to divide by 5 both sides. So I get x equals negative 2. All right. we want to check our answer. And so to check, I'm just going to do it verbally here with you. I'm going to substitute -2 into x here. And I'm going to substitute the 5 in for y on the bottom equation first. So 3 times -2, that's -6, plus 8 times 5 is 40. Is 40 plus -6 34? Yes, it is. Check. Let's do the top equation. 5 times -2 is -10, plus 6 times 5 is 30. -10 plus 30 equals 20? Yes, it does. Check. So we've checked it. So now our final answer, I want to see a nice pretty ordered pair. And the x goes first, so it's -2, comma, 5. Yes, we could have also checked this on Desmos.com. Just graph each line and make sure the point of intersection is at -2, comma, 5 as well. So that is your most sophisticated, most challenging, most difficult way to solve a system using the elimination method. So this is the hardest of this type of problem that you'll see in our IM1 course. Hope that helps.